Okay, welcome everybody to the third part. We will continue our description of models of attention. In the second part, as a very quick reminder, we had the Broadbent filter model and Treisman's Attenuator model, which are both early selection models. That means both propose that information we don't attend to are filtered out very early in the processing before the information is processed for meaning. So according to their models, information we don't attend to, that means information we don't become aware of, cannot influence our behavior because it's filtered out before it's processed. And there was good evidence for this from the shadowing tasks, where we see that people don't really retain anything from besides some low-level physical properties, but no meaning or even able to identify the language of the unattended message. Okay, let's turn to, let's say, a different class of models, and these are late selection models, for instance, proposed by Deutsch Deutsch or by Norman. And they work differently. They propose that all incoming information is analyzed fully for meaning. That means everything which comes in, our brain, our mind analyzes, and for up to the level of meaning. And only then, later on, the unattended message is filtered out, and now we can use the physical properties as before, but we could also select by the meaning of the message because it's analyzed and we have the meaning. So when we evaluate these late selection models, they have a clear advantage. Because we process all information, we technically really can't miss any important information. So it might be beneficial for our survival and things like that. The disadvantage is it's extremely resource demanding. So if you think at a large room with 20 conversations going on at the same time, which are in ear reach, so to say, it's questionable whether our mind is capable of doing that. Okay, so just to put that these late selection models into context, so Broadbent's filter model proposed we have loads of inputs at the sensory level, then we have this attentional selection and memory level, and memory level means here higher processing for meaning. We only get this one filtered out message which is then processed. Then Treisman's attenuator model, still early selection model, would say, okay, it's not filtered out in all or nothing fashion, but instead it's attenuated, so we tone down and suppress the unattended inputs, and then this is forward to the memory level, while the late selection models propose, well, everything which comes in from the sensory level is passed on to the memory level, to the level of processing for meaning. Okay, now let's have a look at some supposedly research done by James Vickery in the 1950s. You probably haven't heard the name, but I'm pretty sure you have heard of the studies he has done. Okay, so before we look at this, let me just quickly introduce the term subliminal. And subliminal means it's below the threshold of perception. So for instance, a stimulus, when we touch somebody, and we could just make this touch so soft that a person with closed eyes who can't see would say, no, nothing has touched me, although you have touched the skin. That then would be subliminal, below the threshold of perception. In vision, you can have a bright stimulus and we can make it less and less bright until people would say, no, I haven't seen anything, although technically there was a stimulus which radiated some light, but we just didn't consciously perceive that. Another way of creating subliminal stimuli might be flashing something so briefly that people didn't see it or report not having seen it. Okay, let's have a look at a little video clip on what Vickery has done. I think that should go here.
Can you subconsciously influence people with subliminal messages? In 1957, marketeer James Vickery inserted the words "eat popcorn" and "drink Coca-Cola" into a movie in a New Jersey cinema. Too short for the audience to notice, but long enough for the subconscious to pick up. Vickery claimed significant increase in popcorn and Coke. Can you subconsciously influence people?
Okay, that plays in the loop. We don't need that again. Let's return to the PowerPoint. So the question is, does that type of subliminal influence work? So for those who couldn't see that properly, so Vickery used in movie theaters flash very briefly in the movie things like "drink Coke," "eat popcorn," and then he looked at whether the sales of Coke and popcorn increased. And I used to do a poll everywhere thing here in the student theater. And most people think it does work, that we can be influenced in that way. Now, if you take a moment before we look at the results in more detail, think about the attentional models we have discussed so far. If you think it might work, or what do you have to put in as an assumption for that to work? What type of information do we need to process? Is it attended information or unattended information? It's probably unattended information, because he didn't want the audience to see the flicker. And then you can think, which model would support this? That unattended information affects our behavior. And that would be probably the late selection models, because the early selection models would propose it's unattended, it's not aware, can't influence behavior because it's filtered out before we have processed it for meaning. So people, even if they would on their retina see "eat popcorn," it wouldn't be processed to a semantic meaning which could have any influence. Only the late selection model would predict that. Okay, so he presented these subliminal messages, extremely brief, every 5 seconds for 0.3 milliseconds. And one reason for this is that we are actually quite good at detecting such brief flashes. So if you go much longer, people will start seeing that and being unhappy about this. And he said that the sales of Coke increased by 18% and that of popcorn by 58%. However, his results were faked. He owned a marketing company and just wanted to sell his services, and therefore he made it up. And there were a couple of replications which have shown indeed that it does not seem to work. However, in the last couple of years there have been 1 or 2 studies showing that in principle such a setup can have an effect on our behavior, and we will come back to that a little bit later. Just another thing I would like you to point your attention to is that in the widest sense, subliminal persuasion, not necessarily this perceptual priming, may sometimes work. And a quite entertaining paper to read is by John Barge and Chartrand from 1999, and it's called "The Unbearable Automaticity of Being." It is in your additional literature folder on BBL, the paper for you to download and read. And John Barge did funny stuff like inviting people into the lab, and they had to learn word lists, so they thought it's a memory experiment they participated. And what he manipulated between groups was that one list of words contained words which are more linked to the schema of being old, like pension, retirement, Florida, things like that. And the other group had neutral words in that respect. And what he then did was, when people were done with the study, he measured the time the people took from the laboratory room to the exit of the building. And those people who had the word lists where the stereotype of elderly was primed took longer to walk back than those who had the neutral, as compared to those who had the neutral list. And therefore he says we can be primed at so many places without being aware of that. That is quite astonishing. However, to note, it's quite hard, let's put it that way, to replicate these studies. So quite a few people see them a bit critically, but still it's an entertaining article to read, and just be aware that it's not totally easy to do. Okay, so returning back to our models of attention. As we said before, the key assumption of late selection models is all information is fully processed for meaning. So, and that includes information which is unattended and which we are unaware of. So, in theory, this unattended and unaware information should have had the power to influence our behavior, according to late selection models. However, his results were fake. He didn't observe any effects. So, in a way, did Vickery disprove the late selection models? And in this way found support for the early selection models, which would propose straight away that this should be impossible anyway? Let's have a more scientific test or look at this. And one of the first studies who really found very good evidence or investigated really properly this subliminal priming was done by Stanislav Dehane in 1998. The task was as follows. It was a very simple task for the participants. They see a number on the screen. In this example, it's 6. And if the number is larger than 5, they should press a button with their right hand. If it's smaller than 5, press a button with their left hand. So very simple, speeded two-choice response tasks. So they should respond as quickly as possible if they can. Okay, but this of course wasn't the whole paradigm and experiment. They had additional stuff. This is the so-called target they have to respond to. Now, briefly before the target, they have shown a prime stimulus, which could also be a number. In this example, it's number 9. This would be a congruent trial, because the prime, which is 9, and the target, which is 6, both require you to choose to respond with the right hand, which is for larger than 5. Okay, now if you present something like this for 43 milliseconds, you can totally see and read that. This is not subliminal priming. So what they did was they included something which is called masks. So some random letters which represented before and after the prime. So for you as a participant, you just see some flicker of the mask, the prime, and the mask again. And you can't identify that in this flicker was actually the 9. And then your task is just to ignore this flicker and respond to the target, which is presented a little bit longer, 200 milliseconds, which is 1/5 of a second. Now, I used to work a little bit in this area of subliminal priming actually myself, and what I can tell you is to get this masking done, it's very difficult. And if you just reprogram it that way, exactly like it appears here, you still can totally read the prime. So you have to fine-tune the timings, the exact font you use, the size of the letters, stuff like that. But it is possible to use masks to make the prime stimulus basically invisible. And I have seen it myself, that, yeah, you could see that possibly some was a little bit flickering, but no chance to identify what you have seen. Okay, so this is one condition. And the other condition is where the prime is incongruent to the target. So people have to respond with, again, to the target 6 with their right hand, but the prime would actually, in this example it's 1, would require a left-hand response. The question is now, we know that from previous lectures, these primes have the power to influence our response. Do they still have this power if they are subliminal and we are not consciously perceiving them? According to early selection models, they shouldn't, because they have been filtered out so early that they can't influence. And note that here the word, the number, is written out as 9, while the target is the number 6. Dehane used all combinations of this, and this was done to rule out that it's simple perceptual priming. For this one to work, they really must process the 9 semantically so that it can prime the target 6 in a different notation. And what did he find? He found a priming effect. It's not tremendously huge. It's around 30 milliseconds, 20 to 30 milliseconds, but it's there. It's reliable. It can be replicated. And you see it also for the mixed notations. So if one is verbal and the other one is alphanumeric. So it can't be perceptual priming. So the Dehane study has provided evidence that unconscious subliminal stimuli can affect our behavior. And it has been replicated in a lot of different variations of this priming, with words and with geometric stimuli, stuff like that. So it's a robust thing. It requires you to fine-tune so that it works, that you don't see the prime. But once you have managed that, and you can be sure it's subliminal, you see consistently effects. It's really robust. However, James Vickery's experiment did not work. So what are potential differences? And one is that in these well-working priming paradigms, you sit in front of the computer and you prepare yourself to respond as quickly as possible to a number. And the prime then is a number. So your whole cognitive system is set up to process numbers to respond to them. And so even if it's subliminal, your cognitive system tries to extract any evidence you can use to prepare your response. So that works well. And the second thing is that the behavior you want to influence with the prime occurs very soon, usually less than a second after the prime. So in these Dehane-like paradigms, if you present the prime earlier and earlier, you see the priming effect fades away. And after 2 or 3 seconds, the prime does not doesn't have an effect anymore. Okay, a further difference is, or put into different words, is that the prime in Vickery's study didn't relate to our current behavioral goals. So it's probably ineffective. So in this example, where I said, okay, you set yourself up to process a number to make this task, already just presenting a left to prime the left hand is probably, it might have a small priming effect, but probably much smaller. But if you think about presenting drink Coke, then it may have no effect at all. I mentioned earlier that in recent years there have been attempts at replicating Vickery's studies, and this might actually be a component where you might find a handle on this paradigm, where you might influence people's behavior. And I think one replication, for instance, has shown that in this type of flickering in a movie, you may affect to some degree what people do, but only for people who are hungry or thirsty. And then this links in with that. You may have a behavioral goal because you have this I am hungry, and then you get presented some information which may sway and influence your choice. When you then pick something to eat, that you pick the primed one than the other one. But again, it's not that easy and straightforward. You just go where flash a little bit and then your sales increase. By the way, it's unethical anyway, so it shouldn't happen in real life there, unless there are proper experiments, and then you would be debriefed and told about this after the experiment. You can be sure it doesn't happen in real life. Okay, now we have the following situation. We have evidence for which really clearly supports early selection models. If we don't attend something in the shadowing task, it's not retained. At the same time, we have evidence for late selection models. Subliminal stimuli are processed for their meaning, or they should have been filtered out. How can we resolve that situation? And there's a further reason why I like this attention lecture as well, because it very beautifully describes how science works, how progress in science works. It started in the early 1950s with the dichotic listening, with the shadowing task, which then led Broadbent to propose his filter model, the all-or-nothing model. For the data which were around at this time, that was the best model. It was fully supported by the data. Then you collect new data and you see, like this, I hear my name in the background in another conversation, which does not fit the existing model. So what you do is you try to improve the model, which then Treisman did with the Attenuator model. You modify your model to make it fit. Then you get new data, which again doesn't fit. Sometimes you have this let's say a line of one models, these early selection models, and which you try to fine-tune, and at the same time in parallel you have a second line of models like the late selection models, and then they are in competition with each other. So you sometimes really have research communities who kind of fight academically against each other and trying to prove their own model and disprove the model of the other one. And then you end up with something like that. You find evidence for both. And then in this example of attentional models, we have been in this very lucky situation that there have been found a resolution exactly to that question. So, which model is correct, early or late? And the answer is, maybe both are correct. Maybe sometimes we select based on early selection models and sometimes late. Then, of course, the question comes up, what determines whether we do early or late selection? The answer to that has been given by Nillie Lavie, who's at the UCL in London, in her theory of perceptual load, or in brief, load theory. So this, in this scientific progress then, is the next step of, we have this decade-old looking for the right word. I don't want to say fight because that's too much, but we have this disagreement or dispute about what is the right early or late selection. And then she comes and proposes and explains how they can be joined together, not into one model, but saying they're both coexisting, and I tell you when is the time for which model. And her proposition was that suppose we have a difficult task. And as a typical example is, suppose you have a shelf full of DVDs and you look for a specific DVD. That's challenging. You have to look for every individual DVD. Is that the right one I'm looking for? And so you need a lot of attentional resources for that. So you devote all your attentional resources to this one search. So the proposition is, in these circumstances, selection is early, so that we have these resources available. Now, when we have easy tasks, and an example would be to find just a DVD among a lot of books, then this requires only little attentional resources. Suppose you have one shelf with books and there's one DVD among them. You usually just go up to the shelf and you straight away will see the DVD, identify it, and can take it out. And because we have so many resources available, the selection is late. We can afford to do the late selection, which allows us to process more information and reduces the risk that we miss important information. Okay, here is the experimental evidence which supports this idea. The task is as follows, and I will guide you step by step through this again. So, again, a two-choice response task. If you see an X, press the left finger. If you see a Z, press the right finger. And again, a speeded task and trial after trial. Z right finger, X left finger, then the next stimulus comes, again press as quickly as possible, then again press as quickly as possible. And as you can imagine, that's not the whole story. So these were the target letters participants had to respond to. In addition to that, distractor letters were presented at some random positions on the screen. They could be related to the target, so it could also be X or Z, or there could be any other letter, like this one. This is a neutral letter, while this one is incompatible. So my target letter tells me Z, press right, but the distractor is priming, so to say, the X, the left finger response. For the participants, it's clear, the instruction is clear, these letters, the distractors, are not task relevant. Please ignore them as good as you can. And when you do that, like in Dehane's priming, although remember this is not subliminal, you find a priming effect, or an effect of the distractor. The distractor is processed. If it's incompatible, people are slower than when it's neutral. And this is the easy task. It's low perceptual load. There's only one potential target letter, the Z or the X, and then one potential distractor. Then she created a further condition, the high load, the difficult task. And here what she's done, remember the example of the DVD among other DVDs, the target letter, here Z and here X, is kind of hidden randomly among 5 other letters. And these 5 other letters were always neutral in the sense they were not Z or X. But it's just a difficult search task where people have to focus and say, okay, where's the target? Where I have to look this string of 6 letters to find a Z or X to know what I have to press. And that's what she found. If you do the difficult task, the distractor has no effect anymore. Whether the distractor, this X, is incompatible or whether it's neutral doesn't matter. You find the same response times. So this shows that the distractor is processed only in the easy task, and therefore the argument that's early selection, but it's not processed and not affecting response times, it's not distracting in the difficult task. And that is a very strong and nice and neat support for this load theory. Okay, let's summarize our models of attention. We have seen the early selection model, which says unattended information is filtered out completely very early in processing based on physical properties of the stimulus. The attenuator model built upon that and says, well, unattended information is only attenuated and not filtered out completely in processing. And this filtering again still works on physical properties like pitch, loudness, or things. The late selection model says all information is processed and processed for meaning and only filtered out late in the processing. And this filtering can happen on physical properties like meaning, like tonality stuff, and by meaning as well. And then finally, because there's evidence for both, Lavie proposed the theory of perceptual load, which says that selection is early in difficult tasks, because we need all resources to do the task. We can't afford late selection, which is very resource demanding. And when the tasks are easy, then we engage in late selection and can make sure we process as much information as possible. Okay, if you have questions, as usual, please post them in the BBL forums, and I will make sure I'll answer them as soon as possible. Okay, thanks for listening. And the next and last and fourth part of this lecture then will be about automaticity. So we are done with our models of attention now.